Here are some more examples that involve rational exponents and radicals. This particular one, let's see what it looks like as a rational exponent. We would take x, the numerator would be 3, the denominator would be 4. Then we would take x on the bottom with a 2 on the top and an 8 in the denominator. Now there's a rule of exponents that says if we have a to the m over a to the n, as long as the bases are the same, we're allowed to say a to the m minus n. So what we can do is we can take 3/4 minus 2/8 and we can simplify that. Well, 3/4 minus 2/8 is the same thing as minus 1/4. Well, that leaves us with 2/4 if we subtract across the bottom and carry the denominator over, and then that reduces to 1/2. So all this is x to the 1/2, which you know now can be rewritten as a radical with 1 as the exponent, 2 as the index, which more simply could just be written as square root of x. On a problem like this, there's probably a couple of ways you could go about doing it as far as the order goes, but I'm going to go ahead and make it a radical. So the base is actually a -32, so that becomes the radicand, which is the thing under the radical, and then we take it to the 4th power and 5th index. Now, it might be more convenient, this is a situation where it might be more convenient to do the radical first to get that a smaller number before we go and take it to the 4th power. Because if we take it to the 4th power, that might become really hard to break down. But if we take the 5th root, 32 is 2 to the 5th. So -32 is -2 to the 5th. And so when we 5th root -32, we get -2. Now, if we take that to the 4th power, notice the parentheses are very important. If we take that to the 4th power, that would be -2 times -2 times -2 times -2, which would be the same as 4 times 4, which is 16. So that would be one way to simplify that. Here's another problem. Let's see how this one works out. Again, there might be more than one way to go about doing it as far as the order goes, but I'm just going to do the first thing that comes to me. When I see a exponent outside a parentheses, I know that that exponent is going to apply to everything inside the parentheses. And so what I'm going to do is I'm going to separate these into pieces. I'm going to say -8 to the 2/3, x to the 2/3, and the square root of xy to the 2/3. Now we can break these apart a little bit more because this is xy to the 1/2 because you could put a 1 power on these and a 2 index on those. And then that is being raised to the 2/3. There's a rule of exponents that says if you have a base to an exponent and then it's raised to another exponent, that you're allowed to multiply the two exponents. So we can do that here by saying xy is going to be raised to the whatever these two times each other are, which if you multiply across the top and multiply across the bottom, you get 2/6, which reduces to 1/3. So we could put this to the 1/3 power. Now let's bring back in the x to the 2/3, and we'll keep the parentheses around the -8. Since it's a -8, it's going to be important to know that that's part of the base. Continuing from there, what we have is, I would focus probably on this because we have a 1/3 power that could be applied to each thing inside the parentheses because they're connected with multiplication. We're allowed to do that. So we're going to call this x to the 1/3 and y to the 1/3 separately. The reason I did that is because if I could separate those, then I might be able to do something with the two x's. You can see I've got an x times an x. Since the base is the same, we are allowed to add the exponents. 2/3 plus 1/3 is 3/3, which equals a whole number 1. So this just becomes x to the first power, or just x. Then we'll leave the y to the 1/3 there, and then let's figure out what we can do with him. Honestly, you could put that into the calculator exactly the way it looks, and you would get the right answer. But let's break it apart by hand just in case you didn't have a calculator handy. What this means, remember, is as a radical, it's a 3 index and a 2 power. Make sure the parentheses stay around the -8 to show that the -8 is all included as the base or the radicand. Now you could do this two different ways. You could square the -8 first and get 64 and then see if that cube roots, which it does. It ends up equaling 4. Or you could also, since the -8 is a perfect cube root, you could cube root the -8 first and get a -2. Make sure you put parentheses around it because all that is being raised to the 2 power. Either way, you'll get a 4. And then let's go ahead and bring down the x and the y to the 1/3. And we could leave the answer like that if they wanted rational exponents as the answer, or we could write it like this if they wanted radicals in the final answer. The last example I want to show you, again, could probably be started several different ways, but I'm just going to go one direction and show you how it could be done. Again, the first thing I usually do is if I see an exponent outside a set of parentheses, I usually try to apply the -3/4 exponent to everything inside the parentheses. So we're going to separate these, apply it to the 16, and then also apply it to the y that has a -8 exponent attached to it. So this is the way I would rewrite it. And then there's a rule of exponents that says if you have y to a power and then raised to another power, that you're allowed to multiply those two exponents. You can do it on the calculator, but you also can do it by hand. Across the top, you get a +24. Across the bottom, you get a +4. If you divide, you get a +6. So all this is y to the 6th. And then the other one, since it's a number, we probably should, we honestly could put that all into the calculator since it's all numbers, but let's also do it by hand to remember some of our exponent rules in case that wasn't a number and sometimes it would be a letter. Well, first of all, we've got a negative exponent. A negative exponent moves things to the bottom or the top, depending on where it started. And we have a 16 that's being raised to a 3/4. I don't need to write a parentheses around the 16 because it's not a -16, and so this will be the same thing as having an exponent. Having parentheses or not having parentheses would yield the same thing. So the negative exponent just moves the 16 base and the 3/4 power to the bottom of a fraction, and it ends up just needing a 1 on top just to have something up there. Then from there, we can rewrite that. Now that we got rid of the negative power, we could rewrite it as a radical. And once again, you kind of have to decide, are you going to put the 3 inside the radical or outside the radical? I'm going to choose to put it outside the radical so that I can go to a smaller number first and then take it to the 3rd, rather than taking 16 to the 3rd and then having to 4th root that. And let's go ahead and put y to the 6th. So the final step will be 1 over the 4th root of 16 is 2, and then we're going to raise it to the 3rd power. We'll still multiply it by y to the 6th, which we could put on top and call that y to the 6th over 2 to the 3rd, which is 8, times 1 is just 8. And that's the simplified answer.